In this video, we'll be applying a quadratic function to geometry. A parking area is to be constructed adjacent to the road. The developer has purchased 340 feet of fencing. Determine dimensions for the parking lot that maximize the area, then find the maximum area. Since our parking area is being constructed adjacent to the road, I'll sketch out a line here that represents our roadway, and then the three sides that represent our fencing will look like this. So we'll have our width, x, and we'll have two sides, identical, and then we'll have one length, which is y. We know that we have purchased 340 feet of fencing, and ordinarily when we're looking at perimeter, the formula is 2 times width plus 2 times length equals perimeter, except this time we only have one length. So we'll say 2x plus y equals 340. This formula is a representation of what we have in our diagram. And in preparation for the next step, I'm going to go ahead and solve this equation for y, so that we have y equals 340 minus 2x. Now we also know that the formula for the area of a rectangle is area equals length times width, but in this case I'll use variables x and y just to remain consistent with the variables in our diagram. Next, I'm going to substitute 340 minus 2x for y into my area formula. So then I have area equals x times 340 minus 2x. I can distribute the x to get area equals 340x minus 2x squared, which you'll probably recognize as a quadratic function. Since we have a negative sign in front of the lead coefficient, then we have a parabola pointing downward. This means that the vertex represents the maximum of the function, and we'll use this information from the vertex to maximize the area. First, we'll use the formula x equals negative b over 2 times a to obtain the x-coordinate of our vertex. B is 340, A is negative 2. So this gives me x equals negative 340 over 2 times negative 2. Working this out, we get x equals 85. So now we know that x, our width, is 85 feet. To find the length, we need to first figure out the area. So since area is equal to x times y, and we modified our formula so that it represented a more traditional quadratic function, a equals negative 2 times 85 squared plus 340 times 85. Working this out, we obtain an area of 14,450 feet squared. So now we have one dimension of our rectangle. We have the area. We just need to find the dimension length, and then we'll have completed the problem. Since area equals x times y, we can say 14,450 equals 85 times y, and then simply solve for y. Divide 85 on both sides, and we find that y equals 170 feet. Therefore, our dimensions, width, which is x, was 85 feet. Length, which was given as y, equals 170 feet. And our area was 14,450 feet squared. This concludes our example. I hope you found it helpful, and we'll see you next time.